Okay, anyway. Okay, firstly, guys, any doubts from what we have done yesterday? Because if what we did yesterday is clear, then today's thing would be we can run away with it at a decent pace. So if you have any doubts, let me know. Okay, guys, now yesterday we closed out on calculation of GM. That means the effect of yesterday we basically we closed out the effect of bilging on the static stability of the vessel, that is the GM of the ship. Today we'll study how does it affect the trim and how do we calculate the drafts if required forward and aft. Okay, now, so as you see here, the bilging of the compartment, if it is not located amidships, then we know it will affect the GM. This is the question we had done yesterday with the compartment located forward and one with permeability. I have given you the question. So that means it will affect the GM. So let's not be under any wrong impression out here. Secondly, it will also cause a change in trim. So the first part of it, effect on GM, is already done. Today we are going to basically study the effect of bilging on drafts forward and aft if the compartment is not located amidships. Okay. Now, tell me one thing. First and foremost, we'll recall the formula for trim, guys. We know this formula for trim. Trim in centimeters is equal to LCB difference LCG multiplied by W upon MCTC. Do you agree with me, guys? This is the formula. Some people may be calling it as BG, or you can call it LCB difference LCG. I'm sure all of you are on top of this formula, right, guys?
Yes, sir.
This will give you trim in centimeters. Please remember that, and you will name it by head or stern depending on whether LCG is greater or LCB is greater between the two, which is greater than the other. We will simplify this formula so that we don't waste time in calculating MCTC. So let's have a look at the formula for MCTC. MCTC formula is W into GM longitudinal GML upon 100L. Okay. Now, if we put the value of MCTC in this formula, it becomes then LCB difference LCG into W. And I put the formula for MCTC here, W into GML into 100L. What happens is W gets cancelled out and my trim in centimeters gets simplified to LCB difference LCG multiplied by 100 multiplied by the length of the vessel divided by GML. This formula is same, only thing is it saves us few steps. We don't have to unnecessarily worry about the displacement. We don't have to worry about calculating MCTC. So we can cut short and use this formula. Do you agree with this formula on display, beta?
Yes,
right,
sir.
guys? Trim in centimeters is equal to LCB difference LCG into 100 into L upon GML. So this is the formula we shall be using. Now, what is GML going to be equal to? GML will be equal to KML minus KG. There is no question of FSC in the longitudinal direction. FSC is for the transverse direction, right? What is KML equal to? We already know KML, KB plus BML and minus KG. That means what I must know to get GML is KG. Now, if the question gives you the kg of the vessel, then yes, GML has to be used and should be used undoubtedly because this is the correct formula. But again, many a times in our question, the kg is not given. So if you see the GML formula here, To BML, you are adding kb and you are subtracting kg. Okay. Usually, for a normal ship-shaped vessel, BML is quite large. It is about 125 to 140% of the length of the vessel. So, for a 100 meters long ship, the BML can be to the tune of 120, 130, 140 meters. Unlike BMT, which is usually 7, 8, 9, 10 meters, Compared to that, BML is relatively large. Okay. So, if kg is not given, then I can't subtract kg. So what I do is, to compensate to some extent, I don't consider kb either. Then I can say that in that case, GML is nearly equal to BML, not exactly equal to, nearly equal to. Why? Because in a ship, if you see, even if you take the kb as half the draft, suppose the ship is floating at 8 meters, 9 meters draft, you'll have 4.5 meters of kb. It is usually more than half the draft because of the lower portion being minor. Okay. And kg of the ship will be what, about 6-7 meters. So the error that will come is about 1, 2, 3 meters, not more than that. So instead of leaving kg altogether unattended, we can to some extent offset it by removing the kb also. And hence, if GML cannot be obtained, it is only if what I'm saying is only if the GML is not obtainable. That means you are not given the kg. So in that case, we will use BML in lieu of GML. We will use BML. Actually, I'm using equal to, but this is nearly equal to, but we use equal to sign. This is the exact formula. This is the technically correct formula. This is with slight compromise, not really appreciable. It's okay. It's fine. It's very slight difference. So if kg is not given and you are not able to get GML, then you'll have to use the BML. But please remember, don't ask me if kg is given, can I use BML? Technically, it should be GML. Guys, any questions on what I have said here? Any questions on what I've said, guys? Tell me, please. Is this formula, simplified formula of trim, understood? Or any doubts? Class, can you please confirm?
Yes, sir. Okay.
It's okay? Okay, very good. So now we go to the questions then. Now here is a question. The first part of the question remains the same. What is the first part of the question? Making the diagram. Which diagram? Side elevation as well as the water plane. Then the second step is also the same as before, unchanged. What is that? Finding the sinkage and getting the final height draft. Okay. Basically, you see, if you go back to this formula, what is it that we need to calculate if we have to get the trim? We need to get the LCB of the ship in the bilge condition. We need to get the LCG of the ship in the bilge condition. We need to know the length of the ship, and we need to calculate the BML primarily in the bilged condition. If I can calculate all these things in the bilged condition, I can just put them in the formula, and that will give me the final trim. It will not give me the trim change. Why? Because I am using final LCG, final LCB, final BML. So obviously, if all parameters are final, then the trim will also be final. When I say final, it means resultant of any initial trim together with the trim caused. Am I clear, guys? Am I clear, beta?
Yes, sir.
Okay. Then once you have the trim, you need to split that trim into TATF, for which you need the LCF. So you will also need the LCF in the final condition. And to what do you apply the TATF? You apply to the height draft. In our case, the height draft will be D1. So we need to calculate D1. So if I summarize this here, that for solving these questions, I need D1, I need LCB in the bilge condition, I need LCG in the bilge condition, I need, what else do I need? I need VML in the bilge condition, and I need LCF in the bilge condition. If I can get these 5 things, I'm done with the question. Then there is nothing left to be attended to. So in the question that follows, our focus shall be on these 5 things. How do we calculate them? I list them here for your information once again. We said we will have to calculate after bilging D1. We'll have to calculate LCG final. We'll have to calculate LCB final. We'll have to calculate LCF final. And once center of flotation is found, we can find the VML after bilging. These are all post-bilging values. And once they are found post-bilging, I can close out the question without any problem. Do you agree, guys? Do you agree?
Yes, sir. Yes.
Okay. So what do I do? First, I make the diagram, which we have mastered over last 2 days. The length of the vessel is 100 meters, our standard ship. Breadth is 20 meters. Floating on an even keel draft of 6 meters. Yes. WL 6 meters. It has a 30-meter long, 20-meter wide compartment whose forward bulkhead is 10 meters from the ship's forward end. So let's say this is the ship's forward end. This is the after end. So the compartment's bulkhead, the forward bulkhead is here. At what distance? 10 meters from the forward end. And then what is the length of the compartment? Length of the compartment is 30 meters. Breadth of the compartment is 20 meters. It does not have any DB. It has cargo of permeability 30%. P.3. kg of the vessel is not given in the question. You can see the question again. He wants us to find out the drafts forward and aft after bilging. Guys, first please see, is this diagram in the side elevation made as per the question, yes or no? Yes or no?
Yes, sir. Yes, sir.
Okay. Only thing is this compartment used to be midship. It has been now taken to the location given in the question. When this compartment gets bilged, I shade the lost buoyancy. The lost buoyancy is up to draft D. This will cause the vessel to sink. I agree, the final water line will be vessel is trimmed. But we are drawing a water line like yesterday for an even keel condition. That means for D1, W1, L1, and obviously then this draft, wherever I find space, I have marked it. So not necessarily that it has to be marked here. That is D1. When the vessel sinks, the water will rise in these pockets. So water will fill up here also. You see, these are the things I'm repeating, and if you keep doing them religiously, you will not miss out. Now I make the water plane at W1, L1. When I view it from top, what will I see? I will see the forward bulkhead of the compartment here. I'll see the after bulkhead of the compartment here. I'll see some cargo areas contributing to intact water plane area. Length of this is 30 meters. Breadth of this is 20 meters. Do you agree with the water plane diagram as well, guys? And some of this water plane will be lost because some pockets of sea water you will see in between the cargoes. Are the two diagrams same what you have been making earlier, or anything that you think needs clarification, guys? Everybody is good with these diagrams? It's a repeat of what we did yesterday, only the compartment has shifted its location, right? Correct, guys? And such a question we had done when in GM also, when we had the forward compartment bills, port, starboard, center question that we did last. So we made a diagram like this there also. Everybody happy with the diagram, guys?
Yes, sir.
Yes, sir.
Now, please calculate the sinkage, write the formula, then I'll write. You lead. Answer D1 is already given, so you know what sinkage would be. It will be 0.593.
0.593, sir.
Very good. 0.593. Everybody to calculate
0.5.
sinkage, guys.
Yeah, already, sir. 0.5.
Very good. Lost buoyancy from the upper diagram is LBD into P. Intact water plane area from the lower diagram, LB minus LBP. 30 into 20 into 6 into 0.3 upon 100 into 20 minus 30 into 20 into 0.3 is 0.593. This gives us D1 of 6 plus 0.593 equal to 6.593. So one thing is obtained, that is D1. Let me put down whatever I'm obtaining, I will put down here in this side. D1 is 6.593. Okay. So one job done. Out of 5, 1 battle won. Next, let's go to LCG after bilging. Guys, what is the in the intact condition? What is the relationship between? I'm asking few questions. What is the relationship between LCG in the intact condition and LCB in the intact condition? What is the relationship and why?
LCB and LCG are equal.
They are equal. Why? Because the vessel is even keel. Yes or no? Correct? Yes or
sir.
no? Okay.
Sir, it will be equal, no, sir?
Yes, correct. You can go back to this formula also, bete.
Yes.
If trim I put 0, then what happens? LCB difference LCG becomes 0. That means they are equal. Yes or no?
Yes.
Correct? Yes or
Yes.
no?
Yes, sir. Yes.
Okay. So, but we don't have to waste time. In such a case, we can just put like this. LCG initial or let me just put it like this. Guys, what will be the relationship between LCG final and LCG initial and why? What we are solving, what will they be?
The
Will they be
LCG
different?
final will be more. LCG final will be more because the weight is increased on the
Which
forward.
method are you using? Which method are you using?
Lost
Option.
buoyancy, it will remain same.
Lost buoyancy.
Are we using added weight method, beta?
No, sir.
So then, if till yesterday the G did not shift. If G does not shift, why will LCG change? LCG would not change, correct? Yes or no?
Yes, sir.
Yes, sir.
So LCG final will be LCG initial. I am giving the reason here in my working. Lost buoyancy method. Correct, bete? Right?
Yes, sir.
LCG initial is equal to LCB initial. Why? Because vessel is on even keel. I'm sure you agree with that also. And for this box-shaped vessel, what will be the LCB initial? Tell me, guys. Look at in the initial condition, intact condition, what will be LCB? L by 2, okay? L by 2. Why? Because, and which will be in this case 50 meters. Why? Because it's box shaped. Am I right, guys? Do you agree with all the three statements? And this is the way you can write your answer. We have given the reason why it's so. Yes or no? Does everybody agree? From these
Yes,
three equations, what do you get? That LCG final will be equal to 50 meters. Yes or no? LCG final is equal to LCG initial. LCG initial is equal to LCB initial. LCB initial is 50 meters. So what does it mean? LCG final is 50 meters. Yes or no?
Yes, sir.
Yes, sir.
So no calculations required. Simple analytical reasoning, and you're able to get LCG final. Don't worry about if this was to be this, if that was to be this. Don't allow your mind to wander. First, absorb what is being explained. Whatever other things, buts and ifs are there, they'll be automatically taken care of as we continue moving forward. Okay. So don't allow your mind to wander here and there. What will happen if they are not equal? What happens if it's not this? What happens if it's not that? Don't worry about that. Okay. So another thing I have got, LCG final is 50 meters. I can write it in one line also if you want, guys, instead of writing 3 lines. If you want, you can save space and write like this. I wrote 3 lines because I wanted to explain and prompt you to answer. Otherwise, you can say LCG final will be equal to LCG initial, will be equal to LCB initial, will be equal to L by 2, will be equal to 50 meters. And the reason for all of them is box shaped, even keel, lost buoyancy method. So you can write in 1 line, you can write in 3 lines. Choice is yours. It doesn't make a difference, whichever way you're comfortable with. Is that clear, beta?
Yes, sir.
Okay. So one front one, D1 obtained. Next front LCG1. Now let's come to LCB final. Guys, what is LCB? What is LCB? I'm not asking value, I'm just asking generic. What is LCB?
Longitudinal center of buoyancy.
Very good. Distance of the center of buoyancy from the after perpendicular usually,
After
right?
the perpendicular, yes.
Okay. And what is KB?
KB, sir, from keel to vertical distance from keel to the center
Distance
of
of the
buoyancy.
same point from keel, correct?
Yeah, keel.
Over last 2 days, guys, all of you have learned how to calculate the KB. You took moments about keel. We'll do the same thing, exactly the same thing. Only thing is, moments instead of being vertical will now become longitudinal about after perpendicular. That's the only change. Instead of taking moments about keel, we'll start taking moments about the after perpendicular. And if I get the moment of the volume of buoyancy about after perpendicular, and I divide by volume of buoyancy, I'll get LCB. Do you agree with the logic that I have given, guys? Yes or no?
Just repeat, sir.
The way you are getting KB, what is the difference between KB and LCB? It is only the difference of the axis. Yes or no?
Yes, sir.
One was from keel, other is from the after perpendicular, correct?
Yes.
So the process is going to remain same. Only the moments will now be about after perpendicular. Does everybody agree now, beta? Yes
Okay,
or no?
Okay. Yes, sir. Yes, sir. Understood.
Now LCB final will be equal to. Now pay attention before I write, and I'll ask you and you'll tell me. I'll write them. For KB, we took vertical moment of underwater volume up to W1L1 about keel. In this entire expression, keel will be changed by after perpendicular. Now we will take longitudinal moment of underwater volume up to W1L1. So instead of taking about keel, the underwater volume moment is now being taken about after perpendicular. So now tell me, first identify the underwater volume up to W1L1, guys. What is the underwater volume up to W1L1?
W1 100 into 20 into
Length
notational form.
D1. L into B into D1.
yeah.
D1.
L.
Okay.
Yeah, yes, sir.
Okay. And what will be the distance of its geometric center, centroid, from after perpendicular in notational form? What will be the distance of its geometric center from after perpendicular?
L by 2, sir.
L by
Very
2,
good.
sir.
Into L by 2. This becomes the longitudinal moment of underwater volume up to W1L1 about after perpendicular. Does everybody agree or any questions, guys?
Yes, sir.
From this, I will remove the longitudinal moment of volume that is under the water but not contributing to buoyancy. Again, two parts of it. First, identify that volume which is not of your use, which is not contributing to buoyancy but gone under the water. Then we'll talk about its lever. So first, let's identify the volume. Please tell me look at the upper diagram. Tell me the volume in notational form.
Small L.
Small L,
small L
small into small b
small
into
b
D1.
Into
D1
D1. What else? Into
Into
P.
P,
into,
sir.
sir,
Into
uh,
permeability.
Into P.
Into permeability. Correct, Bete?
permeability, yes, sir. Yes, sir.
So basically, just for the sake of explanation I'm doing, you're talking of this volume, yes, which is under the water, and with permeability, some of it is not contributing to buoyancy. Am I right?
Yes, sir.
Guys, where will be the geometric center of this volume? The geometric center of this volume will be here. No, let's use the notational form. Let's not rush with the values. What will be the distance of it from the after perpendicular, the lever? Let me call it as x.
X.
Yes, x will be 75 meters. You're right. But I have used the notation x and I put the value also. So if lever is x, then the moment will become LBD1P into x. Yes or no, Bete?
Yes.
And when I remove this from the total vertical longitudinal moment, I'll be left with the longitudinal moment of volume of buoyancy. And I divide by volume of buoyancy. Under Lost Buoyancy Method, it will remain LBD. Does everybody agree with this formula that I have written? What has happened? It's the same KB formula, only thing the levers have changed. Instead of keel now, they are above the after perpendicular. Yes or no?
Yes.
Does everybody agree, beta? Or anybody has any questions before we put the values?
Yes.
So 100 into 20 into D1 is 6.593.
Yes, sir.
Into 50 minus 30 into 20 into 6.593 into 0.3 permeability into 75 divided by 100 into 20 into 6, and this should be coming as it's already given in the answer, 47.525 meters. Yes or no, beta? Please calculate, look at it, satisfy. If you have any doubts, let me know.
Yes, sir. 47.525.
Guys, anybody has any doubts, please review it properly. Because as I told you, if you have understood the last 2 days, you'll not have problems now in Bilging. It's not going to change suddenly to some different level. It's going to be the same stuff. Okay, any questions, guys, on LCB? Please let me know. I'll wait for 10 seconds for you to respond if there is any doubt. Now, out of 5, 3 things are obtained. D1, LCG, and LCB. All in the final condition. All happy up to this point, guys?
Yes.
Okay, let me just go to the next sheet then. Here is the working so that you can correlate to the working on the screen itself rather than going left, right. Here are things. Okay. Now next is LCF. What is center of flotation? I told you earlier also, probably you will remember. It's the centroid of intact water plane. Am I right, guys? Yes or no?
Yes.
Now, in many questions like this one, your LCF final will come same as LCB final. Okay. But again, it is not universally going to be so. And hence, in some cases, you can run away by calculating either LCF or LCB and using the other as the same. In other cases, you may have to calculate both of them. So what we'll do is, though they are going to be same, I will still learn to calculate so that, like we did for KB also, in first example, KB was D1 by 2, but we still learned how to calculate the KB. Guys, if I have to take the centroid of the area, what is my water plane area in the bilge condition? I'm redrawing it here. The diagram is too small, so I don't want to unnecessarily go on that diagram because that is, so this is the lost water plane area of length 100 meters, breadth 20 meters. You have some cargo here of permeability 0.3, length 30 meters, breadth 20 meters, and this is the sum of it is lost here. Do you agree this is the water plane area in the bilge condition at W1L1? Yes or no? Correct, guys?
Yes, sir.
Now, what will I do to get LCF? I'll take the moments of the areas about the after perpendicular, like you used to do in Simpson's rules, phase 1. A while back, we took the moment of the volume when we were dealing with LCB. Now we will take the moment of area. If I take the moment of the whole water plane about after perpendicular, and from there I remove the moment of the lost water plane, what will I be left with? Name that. I repeat, from the moment of the whole water plane area, if I remove the moment of the lost water plane area, what will I be left with?
Intact water plane, moment of
Moment
intact
of the intact water plane area. Fantastic. Correct, guys? And if the moment of the intact water plane area is divided by the intact water plane area, that will give you LCF, yes or no? In Simpson's rules, you used to do no A1 into D1 plus A2 into D2 upon A1 plus A2. Many a times you would have done it, right?
Yes, sir.
Here we are subtracting. We are taking more and removing whatever is not relevant. So LCF, now you will speak as I do here. I'm calculating LCF final. First, in the notational form, look at this diagram that a water plane that I have made. What represents the whole water plane area in the notational form, beta? No values, only the notational form.
L into B.
The capital
L into capital B. What will be the distance in the notational form of its centroid from the after perpendicular? L by 2.
L by 2.
Use notations. Don't go into values straight away. You'll have problems. This is the longitudinal moment of this whole area. From this one, I identify the area which is lost. Which water plane area is lost in the notational form? Please identify that.
The
Small
small
l
L into
into
small
small
b
b
into
P
permeability.
into P.
into
P. Yes,
p. Yes, per
correct?
p.
Yes.
Permeability. Yes,
Yeah.
sir.
And where will be the geometric
X.
center of this one? Here. And what is this? We have already marked. We have marked this as X.
X.
Yes or no?
Yes, sir.
This center will be here. This is 75. Yes or no? So this will be into X. This will be the moment about after perpendicular of the lost water plane. And when I subtract one from the other, I'm left with the moment of intact water plane. I divide this with intact water plane. Intact water plane will be the whole water plane minus lost water plane. And if you put all these values, it will give you back 47.525. There may be a difference in, instead of 5, you may get 6 in the last digit or maybe 4 in the last digit because of the rounding of issues, not anything else. Why I'm saying they're same, just see that now. Let me change to green. Compare this expression with this expression. Compare these two expressions, this one and this one. You see what has happened? These are the same expressions. Only thing is everywhere it is multiplied by d1. If we LBD d1 minus LBPD, that means all these terms are practically being multiplied by d1. Yes or no, beta? And then it's becoming volume. Correct?
Yes, sir.
Okay. Or you can put the values and satisfy yourself. You see, it will be 100 into 20 into 50 minus 30 into 20 into 0.3 into 75 upon 100 into 20 minus 30 into 20 into 0.3. Please calculate and tell me how much does it come. It has to be the same as earlier. Satisfy yourself. So many a times we will not calculate, but if need be, this is how we'll calculate. Same beta?
Yes, sir. 47.527.
5 to 6, 5 to 7. That's around because you know why that error has come? Because here instead of making it as LBD1 minus LBD1P, we have made it LBD, so that draft has been rounded off. The sinkage was rounded off to 0.593. It was not exactly 0.593. It was rounded off, and that is the spillover of that. So they are both same basically. Okay.
Okay.
Okay. So now you should ask me the question, sir, how do I know whether I need to calculate both or can I calculate one and use the same? Guys, what was the requirement of KB being done D1 by 2? When is KB D1 by 2, guys? When is KB D1 by 2?
When the water plane area is
The bilge area is, sir, we can affecting the.
Okay, let me repeat. I think you're trying to say, but probably you're falling short of words. I know, I can make out you know it, but you are not able to express, and this is going to cause problems in orals. May not be in the writtens better, but orals it's definitely going to be a concern. So you need to watch it out. I said KB will be D1 by 2 if in the bilged condition, the water plane area is identical from keel to the bilged water line W1 L1. Yes or no?
Okay, sir.
Correct, guys. If the water plane area in the bilged condition is identical from keel to bilged water line W1 L1. Yes or no? Correct, guys?
Yes, sir.
Yes.
Okay. So whatever is the condition for KB being D1 by 2, same is the condition for LCB and LCF to be equal. Because the volume comprises of area. I'll not give you the reason behind it. I'll not, but just for you to quickly act. In this case, look at the side elevation diagram. in the bilge condition. Is the water plane area same from keel to waterline, W1, L1? Is it same?
Yes, sir.
In other words, I'm asking you, if you were to calculate KB in this question, would you take it D1 by 2? Yes or no?
Yes, sir.
If answer is yes, then LCB and LCF will be same. Okay, guys? Okay. So
Okay.
fourth thing obtained. Okay. Now I'll change to blue marker. We come to the most important part of this particular part now. Recall the formula for BML. All this while you're calculating BMT over last 2 days. Now we are coming to BML. BML is moment of inertia of the intact water plane about an athwartship axis through the center of flotation divided by volume of displacement. Am I right, guys? If you want to go back and see the formula, see it if you're not able to recall. Now, where is the center of flotation in this case? LCF is calculated to be how much? This is calculated to be 47 points. So I'll write LCF also here. We have 47.525 meters. So that means from after perpendicular, somewhere here is the center of flotation. And this distance is LCF or AF equal to 47.525. Do you agree with me, guys? Yes or no? What do I have to do now? Through center of flotation, I have to draw an athwartship axis for BML. I draw the athwartship axis. For BMT, you were drawing the fore and aft axis. Now I've drawn the athwartship axis. What do I name? I would prefer to call it FF. You can name it whatever, so that it keeps reminding you this is the one passing through center of flotation. Now, guys, tell me, I'll do it here in this part of the sheet on the left corner. Guys, do you agree with the formula for BML with reference to my diagram? IFF of the intact water plane upon volume of displacement. If you agree with this formula, then I'll go. Otherwise, you can flip your pages back and see and satisfy yourself. Formula for BML and BMT we did when we were doing applications of moment of inertia, beta. Do you agree with the BML formula, or anybody who has any doubts? Okay, no doubts. Then I continue. This will be equal to, I have two areas. One is whole, other is some of it is lost. So if I subtract the moment of inertia of the lost from the whole, I'll be left with moment of inertia of the intact. So it will be IFF of the whole water plane minus IFF of the lost water plane divided by volume of displacement. Does everybody agree with this also?
Yes, sir.
Yes, sir.
Okay, now you ask yourself some questions and you answer my questions as I'm asking you. Look at the diagram of the water plane area and tell me, is FF a standard axis for the whole water plane? Yes or no?
No.
Yes.
No, sir.
Yes. Yes, sir.
Yes, sir.
Yes, sir.
Okay, so
Yes,
I will
sir.
ask those who are saying FF is a standard axis for whole water plane. Tell me, why is it a standard axis, beta? Why is it a standard axis? Those who said yes, they need to explain. You can't just say yes or no, toss a coin, beta. Please tell me.
The geometric center.
Because now it's center of flotation is shifted here, so it will become the now the
Whole water
standard
plane is whole water plane, my friend. Whole water plane is whole water plane.
no,
Is
whole
FF
water
passing through the geometric center of the whole water plane?
No. Then it will be.
No, there is nothing like then
No.
it will be. Whatever is there on display is there. Facts will
So
not change. So let's
then
not
it will
use riders in our statements. Then and if. There is no then and if. Whatever is there is on display.
Yeah.
So don't you add riders. Then and if nahi hota. There is only this and only this. Okay. There is a lot of difference in this sort of approach, but you will get stuck somewhere. Guys, whole water plane is 100 into 20. Its geometric center will be 50 meters from the after perpendicular. I can call it as maybe G1 or whatever you want to call it, correct?
Yes, sir.
So FF is not a standard axis for the whole water plane, understood?
Yes, sir. Understood.
So you will have to draw a parallel axis through it to be able to get moment of inertia about FF. Maybe I can call this axis as FYY. I ask another question to you. Is FF a standard axis for the lost water plane? Yes or no? Is
Yes.
FF a standard
No.
axis for the lost water plane?
No, sir.
So lost water plane has its geometric center here. We draw a parallel axis through it. Maybe I can call it ZZ. If I have to use the theorem of parallel axis, see, I'm loading my diagram first before I start working better, because I'll be doing with reference to my diagram. Then I will need this distance between the parallel axes. Let me call this as x1 because x we have already used. Guys, what will be the value of x1? Everything is on the diagram on the thing. This is 20 meters. Tell me now. This is 50 meters, not 20. This is 50 meters. Tell me what will be x1.
2.475.
2.475 meters. Okay. Likewise, for theorem of parallel axis between FF and ZZ, I will need this distance. I can call it as x2. Notations are important. Now tell me what will be x2 equal to, beta? It will be 75 minus 47.525. How much it comes? After perpendicular to ZZ is 75 meters. And we knock off AF from it. What is x2 going to be?
27.47.
47?
Yes, sir. 27.475.
475. Okay, 475. Okay, guys. Load your diagram like this. Then only you'll be able to solve it better. Now, next step, I will use box brackets and apply theorem of parallel axis. Now you have to tell me, please feel free to respond. Apply theorem of parallel axis for the whole water plane between YY and FF. What will be the, in notational form it will come? Moment of inertia of the whole water plane about YY. What else do I do to apply the theorem of parallel axis?
Capital L B Q by
Plus area of the whole water plane into x1 square. Am I right, guys?
Yes, sir.
Yes.
Minus, likewise, I apply the theorem of parallel axis between ZZ and FF for the lost water plane. It will be IZZ of the lost water plane plus area of the lost water plane multiplied by x2 square. Does everybody agree? Divided by volume of displacement. Yes or no?
Yes, sir.
Yes, sir.
Just keep with the notational form. Don't be in a hurry to fight for values. Now, I will put these in the notational form. Whatever I'm writing, if you write this much, that is good enough, and this is what is going to guide you automatically. I look at the diagram. Please tell me what will be in the notational form IYY of the whole water plane in the notational form.
BL cube upon 12.
BL
cube upon 12. Okay.
12. Yes.
What is the whole water plane area? L into B.
B.
What is x1? It is x1 square. Now I'm opening the box bracket before I make mistakes. What will be IZZ? So minus IZZ. Look at the diagram. Tell me what will be IZZ of the lost water plane.
BL cube.
Is that BL cube
I-
only?
Into permeability.
PL cube by 12, sir.
Is that all?
DL cube by 12.
PL cube
No, sir.
into P, sir. Into
PL
P.
cube
P,
by
sir,
permeability.
permeability, sir.
First you write
Permeability,
B. No, the better way is write PL cube upon 12. That is for the empty one, and then multiply that by P. Okay.
Yes, sir.
Though it doesn't matter, you can multiply the numerator also, but it is technically you are basically taking percentage of the moment of inertia, right? Not of LB cube P, right? Okay, beta. Anyway, it's the same, doesn't make a difference. Now when you open the box bracket, this will also become minus, guys. Please pay attention to this. Area of the lost water plane is LBP and into x2 square. Does everybody agree what I have put in the notational form here? Please review. Divided by the volume of displacement. Under Lost Buoyancy Method, volume of displacement will be LBD. And now I'll put the values, pick up the calculator and obtain BML.
सर
So
ये
it will
ऊपर में सर माइनस किया है सर आपने सर BL क्यूब जो बिल्ज एरिया का जो निकाला हमने
ये देखो यहाँ पे क्या है, बॉक्स ब्रैकेट देखो इधर, ये माइनस अगर ब्रैकेट के बाहर है, ब्रैकेट हटाओगे तो क्या
हाँ,
होगा,
सर।
दोनों माइनस होंगे
ओके।
नहीं होंगे?
ओके सर
Okay,
यस सर
so this will be 20 into 100 cube by 12 plus 100 into 20 into x1 is on the diagram 2.475 square minus small b is 20, small l is 30 cube by 12 multiplied by 0.3 the permeability minus 30 into 20 into 0.3 into x2 is on the diagram 27.475 27.475 square, you can write clearly, divided by 100 into 20 into 6, and this should give you a value of BML of, it is in the answer, 127.462. BML is equal to 127.462. Please calculate, and if you have any doubts, let me know. There is nothing new you are learning. Its only thing is now you have to start applying more things from what you have already learned. There is nothing new to learn. Theorem of parallel axis you already know. Formulae BMT, BML you already know. It's a question of bringing all together now. But don't get panicky. When we do the next question, things will be much better for you. Okay, it's always the first question, always, because I also take more time in explaining doubts. So there's always some concern that can come up. But if you by and large understood the concept, then I think that should be good. Is the question clear, beta? Is the BML value matching? Calculate the BML and confirm. I have picked up the value from the answer on top, but it has to match. There cannot be anything wrong. The remaining question.
Yes, sir, matching.
Yeah, it will complete in this part. Guys, any questions before I perform the last step of the question? Because now nothing is left. But BML has to be clear, diagram has to be loaded, you have to mark the axis, then only you will be able to close out the question. Otherwise, you will struggle with it. Anybody who's still calculating the expression? If you're not calculating, then I'll close out the question. Okay, now we don't have kg in the question, so we'll use BML. So trim in the final condition in centimeters will be equal to final LCG difference final LCB. Final LCG is 50, final LCB is 47.25. What is the difference coming, beta? Can you subtract and tell me? It's 2.475, am I right? BG will be 2.475, 50 difference 47.525. Yes or no? Here you have the LCG and LCB here, they're written here, beta. Am I right, guys?
Yes, sir.
No, it's not so. It's not so. 475, not 4745. 475. It has to be 2.475. Yes or no?
Yes, sir.
Okay.
Yes, sir.
BG multiplied by what was the formula? LCB difference LCG into 100 into length. What is our length? 100 divided by BML. What is BML? 127.462. Can you calculate the trim in centimeters? How much is it coming, beta? 42 centimeters, is it? 1.9.
194.17.
How much? 1 point?
1.94.
1.94 meters.
1.940, is it? Third decimal place is 0?
942, sir. 1.942.
942 meters. Okay,
Meters.
it is 194.2 centimeters. Now tell me, by head or stern, beta?
By
That
heart.
is important.
By heart.
Compare LCG final, LCB final. Tell me, is it by head or by stern? Obviously, it is by head. Why? Because
Because it
center
is
of
there in the
gravity is
forward
forward of. Okay. Now using the final LCF, use the final LCF, 47.525. Can you split this into TA, TF, guys? Final LCF, use and split into TA, TF. And since she is down by head, apply TA, TF to the height draft to D1 of 6.593 and get the drafts and confirm if your answers are matching. You can execute the last step better. Because if I keep writing on the same screen, it will become messy. See that the answers are matching. You know how to apply TA, TF to the height draft. Height draft is 6.593, the D1. So apply that and see that you get 7.612 forward and 5.670 aft. Don't apply TA, TF wrongly, because usually when you calculate TA first, you by mistake many a times you apply TA to the forward draft. Please don't make that mistake. I warn my class every time. Okay. Anybody else who's not getting the answer, please let me know. Then I can go to the next screen and solve it for you. If anybody is facing problem in closing it out, please don't shy away. Speak up, because next question you should be able to do most of it by yourself with me. Come back with your doubts so that we are fully exam ready as we finish here. Please let me know. See how LCG final was obtained. First see the diagrams, then how D1 was obtained, then how LCG final was obtained, then how LCB final was obtained, then how LCF final was obtained, and then finally how BML was obtained. Once you have all these three things, final means after bilging. Final means after bilging. Once you have them all with you, you can then straight away apply the formula, get the trim, split the trim into TA, TF. Do not forget to name the trim by head or stern. Based on the final trim, you apply TA, TF to the final height draft, which is D1, and you'll get the draft forward and aft, and the question will be complete. Guys, now we come to MMD question. And do you think you can solve this question? Read it. A box-shaped vessel, 160 meter by 18 meter, floating in seawater at even keel, draft of 6.4. Forward held, it's right forward of 25 meters. Whose forward, okay, it's not right forward. Whose forward bulkhead is 40 meters aft of it, forward perpendicular, is bilged. Okay. If the permeability of the hold is 80% and the kg of the vessel is 4.7. Now here the kg is given, guys. So please be careful. You'll have to use the GML. And understood? Determine drafts forward and aft. So what I'll do is I'll keep prompting you and you please take the lead. Then I will quietly follow, and wherever your things don't match and you need clarification, you just give me a shout. Please make both the diagrams. Please make both the diagrams, shade the lost buoyancy, mark all the things that we've been marking. Make the water plane at W1, L1. Diagram should be appropriate to the question. Don't mess it up. Okay. The permeability is
Linkage correct, sir.
0.8, okay, and permeability is 0.8 and kg is point. Guys, what will be the breadth of the compartment? It's not given in the question, and why? What is the breadth
18
of the
meters.
why?
18 meters, sir.
Yeah, it will be
18
18. Why? I'm just asking. Just want to be sure here.
Why?
Because it's a box shape vessel.
No, why box-shaped vessels cannot be double hull or cannot be smaller in width? Yesterday in the box-shaped vessel we had the tanks, no? 6 meter, 13 meter, 6 meter. Yes or no, beta?
So since it's not specified. So.
If it is mentioned like forward or something like
No,
port
beta.
starboard.
No, beta. In a normal
So
general
they
cargo
mentioned-
ship, in a normal cargo ship, you are a single hull ship. Holds extend from side to side, right? That's the better argument. Okay. Intentionally, I had skipped writing breadth. I wanted to check with you why it should not happen in MD. You get stuck. You've taken 18 is fine, but it is because it's a dry cargo ship. Dry cargo ships are usually single hull ships, so they extend from side to side. So you can take that as 18 meters. Good. Okay. Has everybody got sinkage or there is a problem?
Yes, I got, sir.
Okay, you have got. How about others? Please write in the notational form, put the values and get the answer. There will be water visible. And the sinkage is coming as 6.4 minus कर दोगे तो ये हो जाएगा 14.914, is it? Am I right, guys?
Yes, sir. Yes.
Guys, anybody has any doubts? I'm not going to solve further unless somebody needs my support. And you have to be absolutely with zero hesitation. If you're not getting something, please speak up. Don't sit on your doubts. If you're not speaking, I'm presuming that everybody who's logged in now with me is good with sinkage and gets the D1. D1 is then 7.314 meters. Okay. Then everybody in the class next to come to LCG final. This will be equal to LCG initial. This will be equal to LCB initial. This will be equal to L by 2. And this will be equal to 80 meters is the LCB.
Yes, sir.
The LCG final is 80 meters. I've written
Super
50
answer
meters.
15. Yes, sir. That's fine, sir.
That must be a typo error. That must be a typo error.
Yes, sir. Okay, sir.
That's a typo. So LCG is 18 meters. I give the reason here. 1, box shaped. 2, even keel. 3, lost buoyancy method. Guys, is LCG issue clear to everybody or anybody has a doubt? Please let me know. See, you deal, the best way to see whether you know the question or not, don't look at a complete question in one go. Don't have a overview like a bird and looking at the full question. No. Look at the 5 components. D1, am I able to get? Yes or no? If you're not able to get, we only address D1. LCG, am I able to get or not? If I'm able to get, closed. Next, please calculate LC. Now, in this case, first tell me, we will also need GML. So KB will also be required. Okay, let me prompt you now. What will be the
Same,
KB
sir.
in this case?
KB sir, L by 2. Sorry, D1 by 2, sir.
Sorry?
D1 by 2.
D1 by 2. So
Half of
that
D1.
will be, yeah. So please, how much it comes to? 3.657 meters. Am I right?
Yes, sir. 3.657.
Okay. Now, you will also need BMT. Why? Because the question scope has increased. BMT. Why? Because KB plus BMT will give KMT and KMT minus KG will be GML. Okay. So let's also now get the BMT. You all know that the center of flotation will be on the center line somewhere for BMT. So guys, BMT will be equal to ICL of the intact water plane upon volume of displacement. Do you understand this? We have done in the yesterday's question. So can you please find BMT beta and give me the answer? Can you please find BMT and give me the answer? It will be ICL of the whole water plane minus ICL of the whole lost water plane divided by volume of displacement LBD. This you have done yesterday also, beta. For last 2 days, you have used this. So please find, and anybody who's not able to solve or not understanding what I'm saying, please discuss. Okay. Sorry, BMT is not required, beta. Sorry, my mistake. Please don't, it's not required. Sorry, guys. Please abandon it. Please abandon. We need GML, not GMT. Sorry. I stand corrected, will not need BMT. My mistake. I just went in flow of things. I'm sorry for creating the confusion. Sorry. Sorry, guys. Okay. KB obtained, LCG obtained. Very good. Guys, if KB is D1 by 2, will LCB final and LCG final, LCF final same? LCF final
Yes, sir.
and LCB final, will they be same?
Yes, sir.
Yes, sir.
Correct. What is it that you want to calculate? Tell me. What as a class would you like to calculate? LCB or LCF?
LCB.
LCB. Okay. Please calculate LCB. No problem. Whatever you want, you are happy with, calculate that. You write the expression, talk to yourself, write that in the notational form straight. And then I'll write. Mark the lever for the lost space as X. Mark this distance as X. X will be equal to 160. That means 52.5. We subtract from there. We left it. 160 minus 160 minus 40 minus 12.5. Okay. 107.5 guys. X will be 107.5, right?
Yes, sir.
X
Yes.
divided by LBD. Put these values, and does the LCB come as 76.071 meters? There can be a one place difference in the third one. If I've calculated LCF, then maybe can be same, can be 1 point up or down in the third decimal place. Those of you who are able to get by yourself these things, you can go into the exam hall with a lot of confidence, don't worry. But don't go with overconfidence for sure.
$76.069, sir, LCB.
Okay, that's okay. 6971. That is, I must have calculated LCF. LCF will be more accurate because the D1 is rounded off, na beta. The sinkage is rounded off. That is causing that slight difference. Okay. Don't worry. What you got is right. Don't worry. Okay. So live with it. Stay with it. No problem. No issues. Somebody else can confirm if it is 0.069. If it says 69 at that, be it 69. No problem. It's perfectly fine. Because 71 and 69 is only 2 decimal places in the 2 points in the third decimal place. Guys, is the LCB correct? If you calculate LCF in the meantime, you'll get this 0.071 beta. You can try it out. I must have calculated LCF because if given a choice between the two, you should calculate LCF because that will not be affected by the rounding off of sinkage. Anyway, doesn't make a difference. Even if you've calculated LCB, it's fine.
So it's 76.071.
Okay, you are getting 0.7. Okay, then it's okay. Maybe around somewhere some calculation issues. No issues.
Yes.
Guys, if somebody is still calculating LCB, please stop me. I'll wait for you. Or everybody is done. Guys, I'll count 5. If nobody stops me, I'll move on beta. Okay, everybody seems to have got LCB. Fantastic. That's good. Okay. Now, we write here as the water plane area from bilge to keel to waterline is same. LCF final will be equal to LCB final will be equal to 76.071 meters. Okay. Now what is left is BML. Okay. Now with LCF calculated, pay attention now. Some of you may still need more reinforcement of that. Mark the center of flotation on the water plane. Center of flotation is somewhere here on the water plane. With this distance, mark the distances now. This distance represents AF equal to 76.071 meters. Okay. Now I draw a athwartship axis through F and I mark it as FF. Now I write my formula for BML with reference to my diagram. BML will be equal to IFF of the intact water plane by volume of displacement, which in turn would be equal to IFF of the whole water plane minus IFF of the lost water plane divided by V. Okay. Now I'm asking myself a question. Is FF a standard axis for the whole water plane? Does it pass through the geometric center of the whole water plane? Answer is no. Where is the geometric center of the whole water plane? It is somewhere here at G1. At what distance? At a distance of 80 meters from aft, half the length. My second question is FF passing through the geometric center of the lost water plane? Answer is again no. Why? Because the geometric center of the water plane is here. I draw another axis through it, and the distance of this one is x1, that is x equal to 107.5 meters. Now with these distances marked, I am good to mark the distances x1 and x2. Let us say I call this distance as x1, which is between FF and G. I call it as maybe YY. FF and YY, I call it as x1. And this is 80 minus this. So, kitna aa gaya beta? 80 minus 76.0671. Let me open my calculator by my disturbing here.
3.929.
Okay, 80 minus 76.071, 3.929 meters. Also, I get this distance. You mark them wherever you get clean space so that finding them later becomes easier. This will be equal to 107.5 minus 76.071, 31.429. Correct, beta? 31.429. Am I right? Okay. So now, with reference to these new axes and this axis I marked as ZZ. Okay, mark your axis. You will write this formula with reference to this thing now here. IFF of the whole water plane. First, I'm writing this in the box bracket. It will be IYY of the whole water plane plus area of the whole water plane into x1 square minus IZZ of the lost water plane plus area of the lost water plane into x2 square. Whole thing divided by volume of displacement. Mind you, the minus sign is outside the box bracket. Next, I write in the notational form. IYY of the whole water plane will be BL cube by 12 plus area of the whole water plane is L into B into x1 square. I open the box bracket, so it becomes minus IZZ of the lost water plane. If the water plane was completely lost, it will be BL cube by 12. Since there is permeability, it will be in the same proportion. Minus, why? Because the box bracket is removed. L into B into P into X2 square divided by L, B, D. You have all the values in the diagram, put them those values and see that you get BML of 315.436 meters. Yes or no?
Yes, sir. Correct.
Okay. So if you use the notational representation, you are unlikely to get confused. Don't start putting the values from the word go, beta. Put the values at the end and also make sure you learn the proper use of your calculator. Use brackets, BODMAS smartly so that calculator becomes an asset. It's a resource to be used to its fullest in the exam. Think of our times when all these were to be done by log tables, beta.
Excuse me, sir. So I'm getting
Yes.
only audio, sir. Excuse me, sir.
Everybody else is getting the video, beta?
Yes, sir.
Yes, sir.
What's your name?
Yes, sir, we're
Sir,
getting
Rawat, sir. Rawat, sir, I'm getting only one.
Sign out and come back in the meeting, beta. The problem is at your end only, bacha.
Sir, I tried many times, sir. It still seems, sir, only getting
So
audio.
beta, log in
sir,
on the
not-
phone, then log out from there, log in on the phone. You'll have to change the device. Maybe your internet has some, maybe the internet is slow or something. Huh? Because if it was problem at my end, then nobody would get it.
Okay, sir.
You can log in on the phone for the time being, manage on the phone. Though I don't prefer on the phone because these expressions you miss out on important things. But still, it's better to listen to something than completely lose out. Guys, I want every one of you to make sure that you're comfortable with the calculation of BML. If not, please let me know where is the concern.
So I think I got a BML as 504.6 something.
No, you must have used the calculator somewhere wrong. Did you subtract LBP into X2 square?
Yes, sir.
You must have missed out somewhere. Beta.
Okay, sir.
There must
I'll
be
just do one
some calculation
once again.
error you would have done. Some calculation error. Make sure you use the dimensions of this vessel, not the our standard 100 into 20 wali ship.
Thank you very much.
Sir, I have one question.
Yeah, tell me.
Sir, let's say we have solved the question, and with our understanding we did everything right. Is there any way to cross check or verify our answer?
No, beta. There is no inbuilt check. There is no inbuilt check which I can tell you that do this, okay? Because if there was an inbuilt check, I would have told you. Wherever there are inbuilt checks, I automatically tell you, right?
Okay, sir.
So there is no by default inbuilt check that if this doesn't come. Yes, of course. Some things you can see now. That is where is the bilging taking place? Whether it will cause change in trim by head or stern, right? Okay.
Yes, sir.
Now, and दूसरा क्या है कि have faith, trust in yourself. There can be approximate ways, but they will not again be absolutely to the third decimal place or even exactly correct. So it's not going to give you any indication.
Okay, sir. Thank you, sir.
Guys, is BML done? Okay.
Yes, sir.
Yes, sir.
Okay. So now let's get GML also, because now we can't use BML. GML will be equal to, let me change the color so that. Okay. GML will be equal to KML, which is KB. KB was 3.657. PML is 315.436 minus the given kg 4.7. This gives you GML of 314.393 meters. Am I right, guys? I'm picking up these values from the answer on top. Let me take to a blank sheet then. Do you agree, beta? Is that okay? Okay, once GML is obtained, my trim formula is trim will be equal to trim in centimeters. Of course, you can put in meters, whatever for you. LCB difference, LCB. What is LCB final? 76. LCG is 80. So 80 difference 76.071. This is how you can write. Multiplied by 100. Multiplied by the length of the vessel 160. Divided by GML 314.393. This comes to final trim. You can see 368, 2 meters, is it? Does it cause a change by trim by 2 meters? So it seems to be 200 centimeters. That is 2 meters by head. Am I right, guys? Just check.
Yes, sir. It is 2 meters.
I got it from the draft. I picked up from the answer in the draft here. So TA will be equal to trim 2 meters into 76.0. Now I'm closing the final step, which I didn't do in the last one. Upon the length 160. This is TA. TF will be equal to trim minus TA. That means 2 minus TA. You get this answer. Can you give me TA value, beta?
0.95. 0.9508.
950. So 951. Am I right?
Yes, sir. We can take.
So it is 9, then 4, 0.1 meters. Then. Okay. Now the final drafts forward and aft. Height draft 7.314, 7.314. TF. Now TA will go under aft 0.951. This will come here. Here. Final trim is by head. So TF will be added. TA will be subtracted. And the final drafts I'm going to pick up from the answer. That will be okay. Here I can add 13, 1, 5 and 1, 6, 3, 8.363 meters, and 6 point. This is 363. Correct, beta? This is 4 and plus 13. Yeah, correct. So is it 8.363? Have I written wrong in the answer? I have written 8.368. Am I?
Yes,
364.
Sorry?
Yes, sir.
364, 363, same, sir.
Okay. Then that means maybe I have made a mistake here. It's okay. It's okay, but maybe I have done a mistake in adding or subtracting. So that is subject to correction. So you can check if there are no correct errors, then it's okay. Okay. So guys, with this MMD question done, does it give you confidence to be able to handle this type of question at least? What can they do? One thing they can do is they can keep shifting the compartment along the length. Right from forward end to the after end, they can place it wherever they want.
सर ये GML में सर 314.393 सर कैसे है?
Sorry?
GML से
GML is equal to what? You tell me. GM is equal to what? How do you get GM?
So longitudinal distance from
Array,
perpendicular.
how do you get GM is my question. I'm not asking what is GM. How do you
GM
calculate
is
GM?
K minus kg.
Km minus kg. And what is Km equal to?
BM plus kb plus BM.
Okay, so if it is longitudinal, which BM will you use? Transverse or longitudinal?
Transverse.
If you need KML, you will use transverse BM.
It's longitudinal.
So what is the BM longitudinal? Have we calculated that in the screen somewhere? Yes or no?
Yes, sir.
To that, what will we add to get GML, KML? We'll add KB, yes or no?
Mm-hmm.
What did we calculate the KB for otherwise? Why did we calculate this? And it is the working is here, beta. You have not seen this box?
Okay.
समझ में आ गया?
Yes, sir.
KB plus BML is KML minus KG. KG is 4.7 in the question, right?
Yeah.
Sorry, and KG will remain unchanged. Why? Because you are using Lost Buoyancy Method, correct?
Mm-hmm. Yes.
Guys, is that clear? So whenever GML is given, whenever KG is given, you will have to use GML. Okay, we go to the next one and see what it is. Okay. I don't want to complete everything today. Guys, the next question jo aa raha hai na, the next question which we are going to do is okay. Tomorrow, how many more questions? 1, 2, 3 questions more, and we'll be through with the liquid. Okay. Guys, this question is unfortunately a MMD question picked up from Dubey's book. And Captain Dubey's book has, unfortunately, not only the answer problems, it has a severe language issue also. Okay. This 8-meter deep is what I have cut. It is not cut in the MMD or Dubey's book. In Dubey's book, this question comes complete. What do you make out of this question when you read? What is it that you have to do? Don't disregard the words I have cancelled out. Disregard those words. What do you make out from here? A box-shaped vessel, one, and why I have taken up is because there is a problem with this question and it's a MMD question. God forbid if it gets repeated, then you will be unnecessarily caught on the wrong foot. That's why I'm taking it up. Otherwise, such questions should not even be discussed. They're controversial questions. A box-shaped vessel 190 by 25 is floating at even keel draft of 8 meters. There is a watertight compartment 8 meter deep with watertight flat at 2 meters. What does it convey? What does this tell me, guys? Simple English, what does this convey to you in the diagram?
That
there are two watertight flats,
Two
one at
watertight,
2
one at
meters and
the-
another at 8 meters. Yes or no?
Yes, sir.
Correct?
Yes, sir. Correct, sir.
And then it gets bilged below the 8 meter flat, right?
Yes, sir.
If you open Captain Dubey's book, this question is a solved question in his book. Okay. And the way it is solved is as if this 8 meter deep is not there. What I have cancelled should be disregarded actually. So that means it has a DB, no, not the 8 meter deep flat. Okay.
Yes, sir. They have taken only 8 meters from.
No, they have taken only DB. The rest is open on top, correct?
Yes.
So what I'm saying is, okay, here we know that it is from that book. It is solved like this. But if this question comes to me without any reference, what will I be tempted to do? I'll be tempted to make another watertight flat at 8 meters. Yes or no, beta? Correct, guys? Am I right?
Yes, sir.
Sir, can you please repeat your last sentence, sir?
You read this question, you tell me what is your take on this question, beta. How do you, what do
Sir,
you
there are
understand
two
out of this
watertight
question?
flats. The lower
So
one
that is
got
your take,
built.
no?
Yes,
That
sir.
is your take, correct?
Yes, sir.
But when the author has solved it, he doesn't mean that there is another flat. He means only one flat, that is the DV flat.
Okay, sir. Understood, understood.
So there is a problem with the language of the question. Okay. Okay. That is why the question ideally should be this word, as per Captain Dubey's solution, this word should not be there in the question. This should not be there. But in MMD also it has come verbatim. Somebody has picked up from the book. And I'm sure if somebody cannot read the question and correct it, he would not have corrected the solution either. Okay, so the solution also would have gone from the book only. So guys, if this question repeats again, just in your own mind, disregard this. Why I'm telling you to disregard is not, this is what the question means. I'm telling you to disregard only to align it with the solution in the book. That's all. Am I clear, beta? Am I clear, guys?
Yes, sir.
So basically, as per Captain Dubey's book solution, the question is like this. Length 190 meters, breadth 25 meters, even keel draft of 8 meters. Okay, the length there is a watertight compartment. The length of the compartment is 15 meters and its after bulkhead is 20 meters forward of midship. So here is your midship. 20 meters forward of midship is the aft bulkhead. So this distance is 20 meters. So that means this entire distance from here to here will become half the length, 85 plus 20. 85 plus 20, 105 meter. This aft bulkhead distance I'm talking about, this one, right? Half of 190 will be how much? 85, no? No.
95, sir. 115.
115, okay. 95. Sorry, my mistake. 95, yeah, 95. Yeah, okay. 115. You're right. Okay. And then the length of the compartment is 15 meters. So compartment is like this here. L 15 meters. Breadth is not given. So breadth is end to end, then 25 meters. And it has a permeability. Oh, okay. Firstly, it has a dB. Sorry, my mistake. It has a dB of height 2 meters. And then it has a cargo above the dB. Obviously, it can't be in the dB. So that's where the cargo is. Permeability is 0.7. You have to find the drafts. This is how the question has been solved. Can you all solve this question, guys?
Yes, sir.
Okay. Now let's solve it in the class. What's the time? Because this is the last question, or maybe I can, 11:30. Let's take this question. No, what's the hurry? Let's take this question. Can you please, all of you, make the water plane area diagram here? This is now lost buoyancy is only this much. This is D minus H. I think I'll pick up my calculator rather than waiting for contradicting input. And you can keep telling and you can correct me if I'm making any mistake. That's also possible. Okay, let me just open my calculator. Rawat, are you back? Rawat? Any improvement in visibility of the screen, beta?
Yes, sir. Screen is visible now, sir.
Okay, very good. T minus H. 6 meters into permeability 0.7. 190 minus. Guys, please do it independently. Don't copy from the board. And if they are not, because we should be able to figure out if there are any concerns. Sinkage is 0.351, guys. Am I right?
Yes.
Okay. I'll calculate LCF. That will be faster for me to calculate. Y multiply by D. Okay. In this case, now, guys, a word of caution. Will LCF and LC be same? Look at the diagram and tell me. Would KB be D1 by 2? Yes or no?
No, sir.
No, sir.
So you'll have to calculate both separately, beta. Okay. So LCB final. You can calculate now. It will sink to a new draft.
The sinkage would be 0.468, no, sir? Draft is
I don't
8
know.
meters.
Can somebody correct? Is he correct or am I correct? But I don't know.
Sir,
Let's-
0.351.
0.351. Beta, check your calculation.
The
Have
draft
you-
is 8.
And look at the shaded lost buoyancy, beta. Look at the diagram. Have you drawn the diagram?
Yes, sir, yes, sir.
So
I have doubts, sir.
one second,
But-
let me finish with him. Now, what mistake have you made? Do you realize the mistake you made?
Yes, sir, I got confused a little because it is already bilged, no, sir?
So it is bilged, but what is bilged?
The DB.
DB is bilged.
Yes, sir.
Watertight compartment gets bilged above the flat. Read the question.
I got it. Thank you.
Yeah, who had the doubt? Tell me.
I think I'll clear the same doubt, sir. I was confused about this. Now, sir.
So read the question carefully, beta. Read the question carefully. If your diagram is wrong, it is going to lead you to wrong answer. You have to be very, very careful about the diagrams, guys.
Got it.
You can't be careless with the diagram. Please calculate LCB. I'm not going to speak anything. I'll just write the values. Guys, is this coming 93.794?
Yes, sir.
Okay, that's also confirmed then. I'm parallelly calculating. Don't worry, I don't have the answers. Please calculate next LCF final.
सर ये x 122.5 लिया आपने
कितना लेना है आप बताओ? Have I made a mistake? कितना लेना है आप बताओ? Have I made a mistake?
162.5
No,
120.
122.5 sir, correct.
6.351 ले लिया है 8.351 आएगा ना
-2
Sorry?
मीटर भी तो होगा नीचे डबल उसका बल्क उसका वाटर रेट का.
Where will be the geometry? I am cutting short intentionally. Why are you focusing on my working? Have you worked your answer, beta?
हाँ सर
You
कर रहे हैं
don't scrutinize my working. You look at your diagram and do your working. If you keep looking at my working, you will not gain anything out of it. You need to be focusing on your diagram. Stick to very basics. Where is the geometric center? What is this? What is what? Right? What is that volume? How do you get that volume? You need to stick to those basics. I am intentionally not speaking Vita, otherwise you will not learn. If I keep talking everything, if you have a problem, we'll reinforce that part. Is the LCF coming 93.391?
391. Yes sir.
Yeah, okay.
Yes, sir.
It's a 93.391.
Very good. Fantastic. Of course, please find out what will be the LCG final. That will be 190 by 2. That is 95 meters. Now, I'll take it on the next screen. Anybody who's struggling and not getting these, please let me know. If anybody is struggling, please let me know. I'll go to the water plane area with blue marker now. FF. This distance is 93.391. Geometric center. Water displacement is, let's say, YY. This is X1. Oh.
$1.609.
Now we are good to get. My eye is on my diagram, guys. I'm not picking up from anywhere. I'm real time solving with you. And the more you do it, more proficient you'll become. I got it as 370.382, guys. I don't know.
Yes, sir. Correct, sir.
Yes, sir. 370.382. Yes, correct, sir.
Yeah, okay. Now we are good to get the trim.
0.619.
Yeah, I'll just calculate. CG95. So be careful, use the LCB here because they are different. Don't make a mistake of picking up LCF in a hurry. Okay, so that's sometimes people make that mistake also. BML 370.382. I'm sounding you about the possible errors which happen, bete. It's 0.619 meters by head, guys.
Correct, sir.
Now you have to use LCF. Again, be careful, don't use LCB by mistake. Guys, 8.666 and 8.047.
Yes, sir.
Yes, sir.
Correct, sir.
Yeah, those are the answers. Yeah. So those of you who have got, you can assume that you are reasonably in control with the bilging part. Here is the calculation of the final draft test. Now I'm all available to answer the questions. If you see, guys, there's nothing much we have learned today. It's only the extension of what we knew. And therefore, whatever you did in last 2 days, there can be questions from there. But even if the questions are not from there, the concepts are going to continue and carry forward as they have done today. You have seen them. So, guys, has bilging fallen up to this point more or less in place? Yes or no?
Yes, sir.
Yes, sir.
Okay, I'm intentionally stopping here. Actually, I can spend another half an hour and finish bilging today, but I don't want to do that, beta. Don't worry. Okay. Tomorrow, what I'll do is in first half an hour, first half an hour or so, I'll complete bilging, subject to your doubts, of course. If there are not too many doubts and you're comfortable, then I'll complete bilging and maybe introduce SFBM in the second half of the session tomorrow. However, if you have doubts and the session goes in bilging, I'm okay with it. That's not an issue. I'm not hard pressed on time. Now we have only two more things to be introduced here. One is if the vessel was not even keel, because all our questions were taken on even keel initially, and nothing much to learn in that. Only one step is to be added. And then if the compartment has liquid, and then that's completes our bilging. And then one more question which historically came from MV Inship. I'll have a look at that with you. Though your syllabus does not say so, It very clearly mentions bilging of box-ship vessels. But since there is a question in the past and we have the history of papers being repeated without validation, so we'll just run through that also and hedge our risk. Okay. So, guys, happy with bilging so far, or any concerns?
Yes, sir. Happy, sir. Sir,
Very good.
in the
And how about moment of inertia? वो भूल तो नहीं गए पीछे? I hope you're not forgotten that.
सर ये हिंसिप में सर ये कुछ बता रहे थे आप सर बिगिनिंग में, क्या
कुछ
बताएंगे?
नहीं बता रहा था, तुम छोड़ दो उसको भी, जो नहीं सुना कोई बात नहीं, वो मैं अपने आप कल देख लूंगा।
नहीं सर, क्वेश्चन सर मतलब
मैंने भेजे तो थे क्वेश्चंस। क्वेश्चन बता रहा था मतलब आई डिडंट गेट यू।
ये सर आपने बोला था क्वेश्चन भेजेंगे, जो पीडीएफ भेजा आपने वही सर?
वही तो भेजे थे बेटा, भेज तो दिए थे उसी दिन, द फर्स्ट डे ओनली आई हैड सेंट व्हेन यू आस्क्ड मी।
ओके,
I sent you those from last about 10 years paper, है ना?
यस सर। ओके,
वो हो गया सारा?
नहीं सर, मैंने एक
तो और क्वेश्चन लेके क्या करेगा? तो what will you do with more questions if that is pending?
पेंडिंग तो बहुत हो जा रहा है पीछे।
कहाँ पेंडिंग हो रहा है बेटा? मैंने तुम्हें उस दिन भी कहा था, जो मैंने भेजे थे, you should have taken up 1 or 2 questions of those every day, ना? Otherwise it will be pending. I'm trying my best to release videos on load lines, if possible. And that's why I lost track of time today also. I was working on them. So hopefully that should make load line easier to comprehend. So that is one topic that will be done. So anyway.
क्वेश्चन के आपने सर जो क्वेश्चंस के आपने पीडीएफ भेजे हैं सर, अलग अलग, जैसे यूपी है, बिल्जिंग है, एमओआई, एफएससी है, तो ये सर जो जितने टाइप्स है सर, ये सारे टाइप्स उसी में इन्वॉल्व है ना सर? इससे बाहर से तो कुछ और नहीं आएगा, जो आएगा बस
बेटे इसके देखो, बाय एंड लार्ज इसके बाहर से नहीं आएगा। अगर वो कोई थोड़ी बहुत लैंग्वेज दाएं बाएं करता है तो यू शुड बी एबल टू कोरिलेट दैट लैंग्वेज विद इट, दैट्स ऑल। अदरवाइज देयर इज नो स्कोप फॉर एनीबॉडी टू गो आउटसाइड दिस, राइट? For example, I'll tell you, in the last paper, instead of saying find the COP, he said find the thrust and the distance of the point where it can be assumed to be acting through from the base. So now, I have already explained you what COP is. So if you know what COP is, then there should not be a problem in understanding that question, right?
Yes, sir.
So, see, people can tweak the language little bit here and there, but they cannot principally change what has to be done.
Yes, sir.
Okay. So, and even the tweaked language, when we are doing the fundamentals, when we are understanding what it means, and even if letting tweak the language doesn't make a difference. So, don't have unnecessarily fears in your mind. Don't carry the fear.
Correct.
Okay, guys, if you don't have any questions, I would like to sign out then for the day.
सर ऐसा एक दो क्वेश्चन है और भेज दीजिए, कर लेंगे।
अरे किसी भी पास पेपर को उठा ले बेटा, दुनिया भर के पेपर्स क्वेश्चंस हैं। Let me see. These questions we have already discussed, right? This one I have already told you, Captain Dubey's book problem we have seen. So I have already sent you what I have pulled out. Rest you can pull out, take Captain Subramaniam's book. Who has got Subramaniam sir's books, beta? In which Bilging is there? Somebody has in the group?
Yes, sir.
So there is an exercise named Bilging of Intermediate Compartments. Can you take a photo of that with answers and post on the group? Anybody wants, you can do any question from there.